Oh, hello. Is the YouTube watching? Hello, YouTube. Hello. Do we have any viewers? Oh, we go. Alex. Hello, Alex. Subscribe YouTube TV. You would. I know who Alex is. Give us donations. Give us subs.
Super chat.
Super chats. I don't know how YouTube streaming works.
It's like Twitch donation.
Yeah. Actually,
Okay, so
he said yellow. Boy, we have viewers in the chat. I check Messenger. Guys, I need to check all my messages. Holy. I got like 12. Want to get dinner after? No, I don't. Yes, I have it. Yes.
How do you switch that?
okay, so it's one of these parts.
Alright everyone, let's get started. So welcome to our week 4 workshop. So today we're doing motor control and soldering. So we're going to start off today with a bit of soldering. So I'm just going to go over some basic rules on that. So yeah, we're going to do some intro to soldering, and we're going to be focusing on controlling motors with your motor driver. And we're also going to touch a bit on Arduino functions as well as state transition systems. Yeah, so first up, we're going to go over how to solder. So this is mostly for through-hole soldering, as you can see on the right-hand view here. So the basic process for soldering, if you haven't done it before, you have your soldering iron. It's a very hot thing. It's usually around like 300 to 400 degrees. So you basically heat up the pad you're going to solder to with your soldering iron, as well as the little metal piece there that you're soldering to the actual PCB or soldering to. So the idea is you kind of melt up the pad as well as the wire, and you basically feed the soldering. You basically feed the solder into that little joint, and it melts it into the joint. Yeah. So on the left here, you can see some examples of how to solder. So you have on the left there, you have a perfect solder joint. Over to the right on that, you have a solder joint that's had too much solder. One that has not enough. One where your pad hasn't been heated enough, or if you've heated it too much. And the very last one at the bottom there is if you've had a bit of a short circuit. So that's something you want to avoid as well. So today what you're going to be soldering is mostly just wires to your motors, as well as some extension cables to your XT60 connectors. So this is mostly for through-hole PCB soldering, so it's not exactly too applicable. But the mentors at the back will show you today how to solder those as well. So just some general safety tips. So when you're soldering, you want to be wearing safety glasses, just in case some of the solder splits up, and you don't want to get that in your eye. And you also want some fume extraction, just because you don't want to be breathing in all the toxic fumes. Just some more general how to solder, what's a good solder joint look like at the top there. And of course, bottom right here, do not touch the hot part of the solder. So there's a handle on the solder, you want to just be holding that. Don't burn your hands, please. Alright, so that's just some basic introduction to soldering. The most part of this will actually be showing you how to solder. So what we're going to do is one person from each team. If you could line up over at the back there. Willie, could you wave your hand? Yeah, Willie, wave your hand. Yeah, so because one person in each group, just grab your motors and your XT60 connector and just go to William over there, and we'll just start a bit of soldering.
Can you show them which one's XT60? Yeah, show them which parts. Show them which parts to receive.
I did not have a kid.
People are pretty cool.
Yeah, we're all in Yeah, so basically just grab your motors, so this little cylindrical thing here, add this connector here. So this one that goes to your battery. Yeah. And so basically what we're going to be doing is we're going to be soldering wires to these pads here. And we're just going to be soldering some extension wires to these cables here. Yeah, so basically select one person from your team to go solder. So if you guys are doing like, you're gonna have to go around Are there any screws we can use to screw toes?
Also, when's pizza coming?
Pizza? Let it say around like 7:45. Good shit. Yeah, I'm really sorry. These are absolutely crappy screwdrivers with the kind of we have.
Oh, I was going to choose and like, it was such a pain. I'm trying to unscrew.
I'm so sorry, man. We don't have any better ones. We just have these in like mass production.
That's fine.
Yep. This is just a motor. Okay.
Am I looking? And then you press that in. Why am I doing it? What the? Alright, yeah.
And you type and then say it says, you undo it and then you
Which one?
That's how you connect it. Just lefty loosey. Wrong one. These two, bro. These two.
hello, Leo and Alan.
Oh.
When do pizzas come? At the end. Also, why not at the start?
Oh yeah, it's like it's over the end.
Wait, did it work?
I mean, I just want to look like this. Yeah. Oh, sorry, we're just gonna have a quick look around.
Am I just loosening it? Are you loosening it? I feel like it's getting hot.
I check a chair here so no one to minimize the chance of
I'll be okay. On your solder. Oh, this. Is this one? No.
Streaming.
Are these the ends? We need to hold a wheel.
But I don't know what
Where's your
happened.
third wheel?
Oh, that hurts.
Don't come look in the camera with me. I already have to stand in the camera to present it. You're live, by the way. That's pretty cool. You're literally live. It's pretty cool. Let's do a TikTok. Do a TikTok with me. Okay, we're gonna throw it back. Throw it back with me. We're throwing it back on live stream.
Yeah, you go down. Go, you're half
Don't throw it. Come on.
half-time entertainment.
Do it.
You can also sing it. Well, yeah,
That's
you want to see us
awesome.
bounce up and down and sing.
What's that delay?
Okay, now we need to put it back in.
I'm gonna head off. See you guys. Bye.
I actually think we need to solder this so it's more together. Let's check the other ones. Yeah? Do the other one. We need to make it. We just gotta make sure that we know which one it is. Otherwise it won't. Oh, no, tell me that. Oh, this ties up flat. I don't know how to pump it.
Wait, what's Jenny? Yeah, good that no one else got that one.
Yeah, we had like textiles, boosting, IST, and then Qualcomm on board. What is that? Isn't that so big?
It is kind of good. This is like nice. You can do like wood stuff. Oh! We should, yeah.
It was so strong. My queen.
Alright, everyone who's still here is not soldering, so if you're not soldering, you guys just sit back down, so we'll continue on with the presentation now. So we're going to be going over motor control using your actual motor drivers now. So this here is what you've been supplied with. You've been given an L298N motor driver. So this is a 2-channel motor driver, which means you can control 2 motors at the same time. So you have these 6 pins here. So you have enable A, input 1, 2, 3, 4, as well as enable B. So these run on digital. These run between 0 and 5 volts, so you can actually control them using the Arduino. So enable A and enable B, they control the actual power to your motor. So if you're controlling the speed of your motor, you'll basically be sending a value between 0 and 5 volts to enable A or enable B. Inputs 1, 2, 3, and 4, they control basically the polarity of your motor. And then output, they have out 1, out 2, out 3, and out 4 as well. So those are the outputs to your motors. So you have a motor A and a motor B basically, so one on either side. So in general, enable A controls the speed of motor A, and then input 1 and input 2 control the polarity of that. And then on the other side, you have enable B, which controls the speed of motor B. And then you have an input 3 and input 4, which control the polarity of that motor. Yeah, so we'll move on now to actually wiring your motor. So as you see, this is the basic wiring diagram here. And so we'll be wiring input 1, which we've labeled left F. Yeah, so we're connecting that to 4, input 2 to 5, input 3 to 6, and input 7 to input 4 to 7 on your Arduino. So our image here has an Arduino Uno, but it's exactly the same pins anyway. You might have to wait a bit until the soldering is done, but you can wire everything else just fine.
She's like, if she didn't exist, this wouldn't have happened, and last year we wouldn't have been able to do anything.
So enable the speed motor. So imagine like I set the battery in place, right? So imagine say my battery is 6 volts.
We were like, it's like, they didn't give us any money.
So basically what enable does is basically it kind of changes. So it'll be anywhere between 0 and 6 volts, depending on like kind of signal you send to enable A. So if I send say like 2.5 volts, it will send 3 volts. Yeah. In terms of input, so basically what that means is when I say high, so input 1 might run to say this over here, input 2 might run to this over here, right? So if I put a high to input 1, what that means is I'll be sending like my voltage to here. So say we're running 6 volts again, say my enable base is on 5 volts, so I'm setting the max 6 volts, yeah? So if I put this on high, so if I put input 1 on high, this will be getting 6 volts. If I give it a low, this will be getting 0 volts. So on this side as well, so same logic, input 2, if I put on high, and E and A is high, so it gets 6 volts. If I put on low, it gets 0 volts.
I swear we.
So if I get 6 volts here, if I get 6 volts here,
Okay,
I need like,
yeah, you just gotta.
so I want 6 volts here and 0 volts. So I'll make it turn one way. And what I meant by polarity is if I flip that down, so if I send 6 volts here, 0 volts here, it will run the other. Does that make sense? So you control the polarity of the motor, so you make it go forward or back, and then enable A, so that
My car is $2. Oh, nice.
So basically, input 1 and 2, they can start on the they should always be consistent. If you want to try it, they're on the If you want us to do nothing, you just make it And enable A is speed on. Really slow. I completely forgot to talk about that.
Well, in case you haven't heard, ACYA is all about promotion. I don't think you want to hear it. Okay, just to put it, kind of get
Alright guys, just real quick, so this is my bad. I've completely forgotten to explain why we're using a motor driver. So the reason why we're actually using a motor driver is because we're using a 6-volt battery. So these motors run at like 6 volts and quite a few amps. I'm not really too sure how many amps, but that amount of power can't be supplied by just the Arduino itself. You're basically shorted out. So that's why we use a motor driver, where basically we can externally power the motors while still controlling it using the Arduino microcontroller. So that's the purpose of why we're using a motor driver here. And in terms of specifically how each pin works, so enable A and enable B, as I said, control the speed of the motor. So that takes what's called a PWM input. So it's actually like sort of like an analog input. Yeah. And so that will basically adjust the value sent us, the value, like the voltage sent to the motors. So between, in your case, 0 and 6 volts, depending on what you depending on what control input you give from the Arduino. Yeah, and just a note, some of you guys have what are called jumpers on your enable A and enable B pins. So these pins here. So you want to pull them off to actually connect to them. So you need to pull them off to expose the header pin, because basically what that jumper does is it connects enable A and then enable B to this little pin here. So that's a plus 5 volts. So when you put that jumper down, what it basically does is it will constantly give enable A and enable B 5 volts. So basically you'll be constantly running the motors at max speed if you have those jumpers on, but in our case you want to actually control the speed of the motor, so we'll be pulling those jumpers off and we'll be connecting jumper cables to them.
Can you show us which ones?
Yep. So this is real close. So you've already taken it off, so that's fine. So jumpers, you actually have one here. So this one I won't explain. I won't explain it out loud, but that's actually for an onboard regulator. So that's for an onboard like 5-volt regulator. So when you have it on or the regulator, take it off. So when you have that on, so that kind of jumper, basically what we're using there, the outside in here. So this in here and this in here, which you can't really see too well on there, but it's a 5-volt pin. So if you remember, I think I explained DNA on the but basically you send it a value between 0 and 5 volts. If you send it 5 volts, you're getting max output. So basically when you have that jumper on, you're giving it max output. I don't care about speed control, I just want this to 100% always. That makes sense? Someone has, so yeah.
find my profile so I can make myself work.
I did so well.
I couldn't find my profile.
I had it distracted for like 3 months.
Alright, so while everyone's waiting for soldering, let's go over a few more concepts here. So we'll skip over that for now. So first one I'm going to go over is the analog write function in Arduino. So this is for what's called a PWM signal. So in Arduino, we can't actually output a analog signal. So what we instead do is we try and mimic an analog signal using what's called pulse width modulations, or PWM. So this again is to control the speed of our motor, so we don't want to constantly stop or constantly going at full speed. So what we do with PWM, and this here on the right is basically what we pulled up from basically just Googling this. So you can find this on the Arduino IDE website, and that provides a lot of good documentation for every function in, every base function in Arduino. So what a PWM basically does is it rapidly turns a signal on and off. So see here, so 25% duty cycle is what we call it. Basically what that means is 25% of the time you're going to be off. 25% of the time your signal is on, and 75% of the time your signal is off. So what that'll basically do is replicate an analog signal that's like 25% of 5 volts. So using PWM or analog write in Arduino IDE is how we basically mimic an analog signal using the Arduino. The opposite of that, you guys would have already used it, is digital write. So digital write, you either have a high or a low value. So you guys should have already used this already. And once again, this is something we just pulled up from the Arduino IDE website. So digital write is a 0 or 5 volts. And that's what you're going to be using for your input pins. So input 1, 2, 3, and 4. So that's digital write. Yeah, so digital write takes, in terms of an input, so it takes, well, it's pretty small here, but it basically takes the pin number and the value. So the value is either high or low. As for analog write, we'll go back a slide. Analog write, so it'll take the pin, number. It'll also take a value, but it won't take low or high. I think it will take low or high, but most of the time you'll basically be giving a value from 0 to 255. 0 being the lowest, and then, so 0 is off, and then 255 is basically high, which is always on. Let's see. Yeah, so we'll just continue wiring for now, and then we'll go over the actual setup code for the motor control in just a bit.
You're waiting for my next number. Zap you? So you're explaining it to me.
Might start. Yeah. Yeah, good idea.
Look at this brand. Probably buy my own picture.
If he has enough badges, right? How many does he need?
I did it during the summer. Shit. It's so bad.
I have a mental badge somehow.
That was such a HD to before. Like it's so easy. No, I already took two.
I need more.
It's just that one fucking sentence. But the rest was literally like
Okay.
See, you just need to get the rest of them and then make it organized, right?
have it on the screen. You just say you have to like unscrew it. I should have brought my camera. I didn't convince my parents.
I eat arcade.
Yes. Until you got 40 credits. You just took turn up?
No, I just
Yep.
Oh yeah,
Yeah, and then they didn't allow me to do it, so I could go back.
like a lecture or something.
Trying to figure out.
And like, yeah.
Have you been marked for you to do?
that is not meant to
I don't know the way that I first programmed it,
that's
I just added order. So I
Yeah.
was writing that. And then,
Oh no,
That's what I
but
either they
so then when I got marked today, I got marked today, and I was like, oh yeah, I'll put it at this end. It was exactly how I had it. Before I was looking at them. No, it was not. But I had it just left. I shouldn't go crazy.
Yeah, then so friends sacrifice.
Instead I spent a few hours actually fixing it. Because all that work, he thinks the wrong ankle had already like gone through.
Yep. How do you identify the file?
How'd you go for it? I got 2 marks. It was lucky because somebody stacked up on the effectors of the... You know how pointy things are at the bottom?
yeah,
Yeah. Yeah. So we were obviously every person was that machine. Because the rest of them they set the high pad. So it's like points and above it with the pointy tool.
wait. So something like the point is
The pointy thing, yeah, pointy thing is stacked up. So we all got marked. We all decided to get marked on the broken one.
because you can't really back it up.
you gotta get the
Because you're gonna actually like a pen wasn't going across the game.
Is he annoying you? But it wasn't.
Like
Yeah, the other one that was basically hidden tape.
Well, you wanted the big honcho.
Oh no, Eric! Wait.
Oh, yeah. Shit.
Good question, but
Leonard,
as typically
who's Eric?
Our cute was the one.
Who's Eric? What? I want to know who's Eric. The troll.
so there was basically 4 or 5 people who marked.
No one knows, man. Honestly.
And I don't know what.
Oh,
there were people in the other lab who got marked as well.
He's like, how do
What are
you
you asking?
He's like, I was like, shut up. And then, I was like,
No.
and he's like, how do you know Danny? I'm
Also,
like,
the
wait,
only people actually using the robots.
PPS.
So I don't know.
Oh, you're the guy that you're the Discord.
Danny. Danny. Oh, Danny.
Yeah, they didn't even try the robots.
Danny Wayne from
Oh.
I don't think they used it.
Oh. Did you take a photo of it? Doing what? Yeah, we were. You wanted to come next week, but we left that up. Yeah, honestly, it's fun being here. It's just that. So, yeah.
No, the thing is, it's not supposed to be done obvious at all.
We're just gonna go back to soda one day.
Things like that. This robot should not be able to do blood radios. And then, yeah. This was like, I'm drawing a straight line.
Alright guys, so we're going to be moving on a bit, so you can continue wiring and you can do it a bit later. So we'll be going over the code a bit now, just because we're starting to run out of time. So this here is the setup code for your motor control. So as you can see, we basically define, so similar to how you wired it and the wiring diagram, we basically define all the pins here. So we have all our left F, left R, right F, right R, so that corresponds to all the input. So that corresponds to input 1 to 4. We also have here pins for E and A and E and B, so left speed and right speed. And we've also defined a max speed as the value 255. So this is basically some basic setup code. And here in our void setup, so that's where we basically define all our pins. So basically we're sending all these pins to output. So we're going to be giving outputs to those pins to the motor driver. And we're also going to be using the serial monitor, so we're doing serial.begin, and we're using 9600 baud rate. And we're just printing a message to ourselves setting pins for motor. So this is the basic setup code. Yep, so these slides will be available after, I'm pretty sure they're actually already on the Discord, but they will be emailed to you as well. For now you can just basically copy it off the screen.
Just give them your superior motive your superior It's like one big room.
Yeah. Have you seen the Sumobots plan? It's very detailed. Just use the hammer. Oh shit, hammer. We just, you know, like, go fast, whack, go really hard. So even when you take off the two screws in the end, you can try. I don't think I want to do it. Oh yeah, so they usually work like that. Is that the organizer? Do you guys place it somewhere? Because that's something that's being called.
Yeah, you got it. Robots. And then there's like second dog. You can place it on the robot. So it's not oriented. So it's the things take place. Yeah. So it's like the first thing they say. Yeah.
Yeah, but like, not cool at Sumobots, it's not based on Sumo. It's based on Sumobots. Are we allowed to put girls on things?
Oh, I get what
Oh yeah, what happens if their robots actually fall over? No, I know. Like, couldn't you technically make your thing designed to fall over? So then, so that it just falls over, and then with the benefit of your robot, like,
yeah. I guess that's why you can't
you lose if yeah.
No, if you flip it, like,
So we just use the wheels like this.
oh yeah, by the way, I guess it's not
We just need to switch these to analog. Rotating power. Yeah, I know.
Can we put word wheel in the front? Just spin very quickly.
Oh yeah, now boss can write something with or yeah. We'll have one of those next to it. Just make a secondary mode of this.
I dismantled that.
Yeah,
My main one.
just still in a if you make one, then it's fine. The other one melted. Why would anybody want to go to Windows? No, right? So I think they wanted you to go to Windows. I'm pretty sure my grandparents still use it. Because that was really good. Oh, wait, no. Then my uncle ended up getting it on that. And now they just have this for their computer.
they just learn how to use Windows.
Yeah, they just learn how to use Windows, and then there's not thinking of a Mac. You know the special Mac in house, whatever? Yeah. That was my what? Why would you tell him?
Yep.
Have you been using the best account on YouTube?
And then he searched up Mao Zedong song.
So this is the setup though, so this is like the first. You better not delete this. That's just screw up.
Can we actually look at the best friends?
Yeah. You want to be really. This code make sure you don't delete it. Maybe like setting it up. Like how on the side.
So this is just the setup code. I'll be going over that like pretty much now. Yeah, so this code, like, you can't like copy paste it, it will be in the
Hand
presentation
way to
slides when
work
you get
out how to code C++ and ROS. For example, SolidWorks tutorial. Sweet trip conversation.
Alright, so we're just gonna go continue on now. So the next part of this, after you've done your setup code, is to actually write the code to make your motors actually move and drive. So the code here, what we have here is basically driving forward. So what we've done here is we've given an analog write to our enable A and enable B pins, so speed controls, and we've set them at max speed. And then for our input 1 to 4, and then so those are for controlling basically the polarity of the motors. So basically we're just setting one side to high and the other side to low. So same for both motors. In terms of which direction they're going to move, we don't really know until we actually run the code. Otherwise, yeah. So that'll be connected to your battery. You want to solder an extension to this, because what that you will need to go into is another one of the screw terminals.
Okay, thank you. We might get on.
And you'll see for reverse, it's basically the other way around. So we're still writing max speed to our enable A and enable B pins, so our speed control, we're still giving a max input. And then the only difference here is that we've actually flipped the polarity. So before, you noticed on the previous slide that we had a configuration of high-low, and basically to run the motors in reverse, we basically just flipped them around. So now they're low-high. So yeah. So basically, just to control which direction your motors go, you flip which input pin is high and which input pin is low. So that's all you need to do is to make it drive the other way. Yeah. So you guys continue. You guys can continue wiring for now, and if you guys need any slides up, just let me know. So we do have a bit more after this as well, but give it a bit more time.
Star Wars.
Oh, you here?
I'm bored.
Yes.
I mean, I was meant to go pick up pizzas, but then I did. Why? I thought there were so many things on the house.
It's fun to see.
Spend enough time teaching robotic design in the actual class. I don't do bits. I don't do put on my own to this. Teach how to design robots again.
But it's but now you get to, it's not about teaching it, it's just about being there and then being able to touch the thing. Because, robot design fun, but here we get to,
If you see the teaching teams icon for one that's my Sumobot that made my project. It looks terrible because I switched right from my subdivision game. I wasn't, but I am now.
yeah, you should be here in like 10 minutes.
That's not why I have this now. I carried this thing all the way from.
Oh, yeah, I didn't even see it, it was in your hand. I didn't even see it.
And that parade to Nira and do 200 spots, 300 bicep curls with 5 kg on hands. In about half an hour to do for the sake of doing experiment. And I'm not paying back my money.
Wait, do you?
Yeah, I look at what I'm international as well.
Wait, you're not on camera?
I'm supposed to be to came I'm on campus.
Mahjong? I don't know.
He doesn't know how to play Mahjong.
Card gambling.
I have such.
What kind of card game? Wait, that's different.
I mean, I got Avalon, Secret Hitler, I got
Avalon's like I love Avalon so much.
I got Close Names. I don't. My husband thinks it's hard.
I've never actually played Catan, but everyone talks about it all the time. I don't know.
So that's why I feel when I walk on main walkway this morning, all the way from Ring District to my office. I'm like, shit, everyone just thinking this guy's sick.
Is that just from home? You just have a...
Yes. This guy is just sick, I don't know. And I try to do like some demos during my office as well. And some CSE lecturer was like looking at me in a real way and yes, I have a stuffed Eddie.
Oh yeah, that's so cute.
I thought you had known that. I thought you.
Can I get an associate lecture position?
I don't know.
Do you get paid a lot?
What's the hour?
Slightly higher than tutoring.
It's not a huge amount.
It's not a huge big
I was
file.
having, you have to receive. Oh my god.
I didn't go.
It's slightly
Yeah, you guys are live on YouTube.
Oh yeah, we are live on YouTube.
Oh, thank you.
It was good, but it went very smoothly. We got through everything, but a lot of students I just keep telling them, like, things that you're using now, you just need time to review the lecture, and then you know how they work. Yeah, basically, I told them just robot. What do you want to do? Yeah. That was the thing that I just kept saying. Like people I can see that people weren't getting it, and I said, it's not real.
We had a lot of questions today, which took some time out of the I think this is more like a lot of people like
Alright everyone, so we continue on with the presentation now, so we'll be going over the last section, which is system integration. So first topic in here, so we've actually got functions. So if you've done any kind of coding course ever, you'll know all our functions, but in case you didn't, so functions are basically chunks of reusable code that you can basically call from anywhere within your code. So they're really useful because they basically make your code a lot more make it a lot more readable, and you know, it helps you understand and follow what your code actually does. So here on this one on here we have an example of the structure of the code. So the example we've given is dash line. So we have here the return type, which is void. So that basically means we're not returning anything. So I'll go over that in a bit. Then we have the function name, which here we have is dash line. And then we have these two parentheses here, which is to take in inputs. So this function at the moment doesn't take in any inputs. Again, I'll go over what that means later. And then between these curly braces here, we have the actual body of the function. So that's what the actual function will do.
Hey, can we get a bit more quiet? Hey, can we get a bit more quiet? We're doing presentation. There are some people who are listening, so if you can please be a bit more quiet, that would be appreciated. Thank you.
Alright, thanks everyone. So first example we have here, so these slides will be available to you afterwards, so don't worry too much about copying this down. If you already have the code though, it is basically just copy pasting. So here we have an example, so we've basically moved the driving forward and reversing into their own separate functions. So again, we have the return type, which we're not returning anything, so we're using the return type void. And again, with the function names, we want to have them be meaningful. So we have drive forward and drive reverse. Yeah, they do what the function name says. So here we have an example of our main loop here. So essentially, if we're trying to drive forward and drive back for a second each, this is what originally we have on the left here. So it's just kind of like a mess of code. We don't really know what it does, and it takes up a lot of room. But using functions, we can actually write it like this. Nice and compact, and we read it, we know what it does. Drives forward for a second, drives back for a second. Yeah, so the next part, so functions can actually take an input and also return a value. So in terms of taking an input, so the class parameters are defined here. So here we have a function called multiply function, or my multiply function. So this is taking two inputs. So it's taking integer x, it's also taking another integer y. And basically what it does with that, with those two parameters, it basically just multiplies them. And you'll see here, the return type here is int. So basically what that means is my function will actually return an integer value. So that's important here, so we have int result, and here we're saying return result. So what that basically means is when I call this function, I pass in an integer x, I pass in an integer y, and my result is going to be an integer x times y. So with that, you can actually use functions for various purposes, so you can reuse the same code with a bit of modification. And so just some additional concepts. I won't go over too much in detail on this, but there's things called local and global variables. What that basically means is that some parameters that you define in your functions, you won't be able to access outside of your functions. So for example, here we have This is actually Python code, so don't worry too much about the syntax. So we have a function here called foo, and we define variables x and y here, okay? So those variables x and y, we will not be able to use outside that function. So we have another for loop here, x and y. We also have an x up there. All of those x's are different to each other.
And kill you.
So in terms of how to use this, so we have two new functions here. So we have a drive at speed. So basically we're driving with variable speed. So we have a function named drive at speed. We're not returning anything, so we're using the return type void. This time we're taking an integer input called speed. And basically we're using that speed to control what value we give to our analog write function. And same for your ultrasonic. So with your ultrasonic sensors, instead of constantly copy-pasting that same code over, we can use a function called read distance that returns a float value. So basically, you copy-paste your ultrasonic code in, and you make sure that you have this little part here, which is return distance. So basically, every time I call read distance, it will return the ultrasonic distance to us. So there's an example here on the right of a basic loop. So basically, I've called distance equals read distance, and I'm going to be printing that out on the serial monitor. And following that, I'm going to be driving for max speed at half a second. I'm going to stop for half a second, and I'm going to drive at about half speed for another half second. So you can also write code for turning as well. I'll leave that for you guys to do. Won't go over that. There's also a random function here. You can try and work out what it does. Alright. So the last part of what we're going to go over today is system states, or otherwise modes. So this is going to be really helpful for you when you're trying to put all your code together to make your Sumobot. So basically what this means is you're breaking your system or your Sumobot into various modes or functions. So each mode basically performs a specific task, and that's separate to each other mode. And with that, each mode has a specific trigger that'll basically make it transition to another mode. So we have an example here of a basic ATM system. So at the start, we wait for a card to be inserted. That mode, we're basically just waiting. We're checking if a card's been inserted, and once a card has been inserted, we move to the next mode. So the next state is waiting for the pin. So basically waiting for the pin. Once we get the pin, we check if the pin is okay. We get access to our account. If the pin's not okay, we go through the next try and so on until we try too many times and the ATM system eats our card. So how this is done in code for our Arduino is using this little setup here called switch case. So essentially what a switch case is, it's a series of ifs and if-elses. So basically I have a condition. So what this means is if condition equals 1, I'm going to run this body here. If condition equals 2, I'm going to run this bit of code here. Otherwise, this is basically our else statement. If condition doesn't equal any of our cases here, it runs what's in default. So that's basically our else statement. So switch case is basically like an if, else if, and so on until the bottom where we call an else. So the example we're going to use for our Sumobot, is basically a motor starting and stopping based on the ultrasonic distance. So we're going to start in mode 0 here, where we're going to be constantly reading the button. So in mode 0, we're just reading the button, and once we get our input, so the button's been pressed, we're moving on to mode 1, where we're just waiting. So we're waiting, 3 seconds have passed, and we switch to mode 2. So this is similar to your start, where you're basically pressing your button, and I think you're waiting 5 seconds. So you're waiting 5 seconds, doing nothing, and then you start all your movements. So mode 2, we're going to be driving forward, constantly driving forward, and we're also going to be checking our ultrasonic sensor. So we're checking our distance. If our distance is less than or equal to 5, we're transitioning to mode 3. So mode 3, we're basically going to be just stopped. And in mode 3, if our distance, because we're still going to be checking it, if our distance is greater than 5 again, we're moving back to mode 2, where we're driving forward again. So basically what this does is it's going to keep driving towards an imaginary, well, it's going to be driving towards a wall constantly and stopping whenever it gets within 5 centimeters of it. Yeah, so this is, in terms of translating that into code, this is basically what we have here. So starting on the left there, so we define our integer mode. So I define my integer mode and I give it an initial value of 0. So I call int mode equals 0. Then in my void loop, I'm going to be constantly calling read distance. So I'm going to be constantly reading the ultrasonic distance and I'm going to be trying to just get that distance. And then I call my switch case here. So I'm going to switch mode equals 0, and it's going to be reading my button. Yep. So I'm going to be constantly reading my button. Once that button has been pressed, so I have if digital read button equals low, I go mode equals 1. So that's my trigger. So my trigger is my button, and with that press, I move to mode 1. In mode 1, I'm basically just doing nothing for 3 seconds. So I just go delay 3000, and after 3 seconds, I move to mode 2. So I move to mode 2 up here. So mode 2, I'm just driving forward. But at the same time, I'm going to be constantly checking if my distance is less than or equal to 5. So if my distance is less than or equal to 5, I change mode again. I change mode to mode 3. So back to our state transition system, it's the same thing. So mode 3, I've stopped. But I'm still checking my ultrasonic distance. So if distance is greater than 5, I do mode equals 2 again. So again, it's the same thing. So again, it's the same thing as what we have here. We're just transitioning between systems given a certain trigger. Yeah, and then here I also have a default here. So if mode does not equal any 0, 1, 2, 3, if mode has been given, say, 6 for some random reason, I'll be default. So if my mode was not any of the above, I'm going to just set mode to 0 again, and I'm just going to stop there. Yep. Sorry?
Technically, depending on where you go, it could be a global so technically have access to mode anywhere.
Yeah. Does anyone have questions? Any questions on that?
Make sure people wash their hands.
Yeah, I just one more part to go.
Yeah.
Alright, so last thing for today, we're going over the Miller's timer. So this one's going to be real quick. So the Miller's timer is basically an internal timer on the Arduino that counts the number of milliseconds since your program is started. So this can be used instead of delay for timing your movements. So the problem with delay is that it actually completely stops your code for however long you're stopping it for. And what that essentially means is you can't check your sensors, you can't update your movements. You're basically driving blind for however many seconds you've set delay for. So so if you're delaying for say 5 seconds, that's not great. However, something like your ultrasonic sensor, for example, uses a delay of 10 microseconds. So that sort of delay is fine, in which stopping your code for 10 microseconds really doesn't matter. So it's just a bit of an example on the left here. We don't really expect you to use it, but you can use Millis for timing sequences of movements rather than delay, so you can actually simultaneously update your sensors and update all your controls at the same time. There is also a microsecond equivalent to Millis, which is called Micros. So yes, some additional features as well. So there do exist interrupts, which again we don't expect anyone to use. And there are also tabs in the Arduino IDE, which can be helpful for organizing all your code.
Really?
Alright, so that's the end of today's workshop for today. So you can continue wiring and soldering for now. Although we'd like you all to clear out by 8 o'clock, please. There is also pizza outside. If you guys have been soldering, just hold on for a second. If you guys have been soldering, please wash your hands first, because we have been using leaded solder. So again, if you've been soldering today, please wash your hands before going outside to get your pizza.